This is the introduction to section 10.6, introduction to section 10.6 part 1, talking about circles and arcs. And we're going to talk about finding the measures of central angles and arcs. And then we're also going to talk about, and this will be in part 2, circumference and arc length. That'll be part 2. Part 1 will be find the measures of central angles and arcs. Now, definition of a circle. A circle is a set of all points that are equidistant from a given point. And that point is called the center. You name a circle by its center. So circle P in this case would be, you'll see a lot of this symbol right here where they put a circle with a dot in it and then P as shown below. Okay, now there's a lot of vocabulary here. And as we look at this vocabulary, this is all going to be very important. Okay, so it's going to be very important that you read through this. I'm going to kind of vaguely cover it. And it's going to be important that you read through it and study it here. It says a diameter is a segment that contains the center of the circle and both its endpoints on the circle. So essentially, in this case, you'll notice here that AB is a diameter. From point A to point B is a diameter, and it goes through the middle of the circle, or goes through the center. A radius is a segment that has one endpoint at the center and the other endpoint on the circle. So PC here is a radius. It starts at P, which is in the center, and it goes to the outside of the circle. So essentially, a radius is half of the diameter. Okay, so maybe you want to put something in here. Maybe a radius is 1/2 of the diameter, or the diameter is 2 times the radius. That might be something else you want to put in there as well. Congruent circles have congruent radii. Radii is the plural of radius. So in other words, if you have two circles that are congruent, all of the radii, any radius that they have, are going to be the same. A central angle is an angle whose vertex is at the center of the circle. So you'll notice here we have angle APC as a central angle. Here is A to P to C. It's an angle that goes through the center. The vertex is at the center of the circle. Okay, so essentially, a central angle is going to have the letter of the center in the middle of it. An arc is a part of the circle. So an arc, I could say arc AB, this is arc AB, the distance around the outside from A to B. A semicircle is half of the circle. In this case, AB is a semicircle. Cuts it in half. In other words, it's a line that uses the diameter to create half the circle. A minor arc is smaller than a semicircle. In other words, it is less than 180 degrees. A semicircle is exactly 180 degrees. Okay? A whole circle is 360 degrees, so half of that is 180. A minor arc is less than 180, and a major arc is more than 180 degrees. It's larger than a semicircle. So, for example here, if I were to look at this, then I would say that ABC, arc ABC is a major arc because it's more than 180 degrees. Arc BC is less than half the circle, that's a minor arc. Again, you name a minor arc by its endpoints and a major arc or semicircle by its endpoints. And another point on the arc. So, another thing here to put down as you look here at the bottom. It says here we have arc RS is a minor arc. RS, minor arcs are always with 2 letters. And major arcs are always with 3 letters. This is just the 2 endpoints on a minor arc. And this is the 2 endpoints and 1 in the middle. Okay? So 2 endpoints and 1 in the middle. In this case, STR, S to T to R, is a major arc because it's more than half of the circle. Okay? And you'll notice again we name that with 3 letters. Okay, now let's take a look at some examples of naming arcs here. What are the minor arcs of circle O? Okay, again, this arc symbol is just this right here, this little arc type symbol, like a half circle. Okay? What are the minor arcs? The minor arcs are less than 180 degrees. So I need all of the small arcs. They're all going to be 2 letters. In this case, I'm going to start out with AC. arc AC from here to here, that's less than half of the circle, because half of the circle is AE, which in this case, what are the semicircles of circle O? Half the circle is a semicircle. Arc AE is a semicircle. And as a matter of fact, we can't name that AE because it's a semicircle, so it's got to have 3 letters. So we could go ACE with the way we went that direction. That would be an example of a semicircle. Okay, so let's go back to minor arcs again here. Again, minor arcs are all 2 letters, less than 180. So if I go CE, that's also a minor arc from here to here. If I go from E to D, that's a minor arc. Again, from E to D, it's less than 180 degrees. And then if I finally go AD, that is also a minor arc. All 4 of those are minor arcs. They are all less than 180 degrees. Now, let's go to semicircles. These are all halves. Half circles. ACE is 1. I could go CED. If I go from C to E to D, that's half the circle. CD is a diameter. Okay? I could go EDA. That is a semicircle. Again, semicircles are with 3 letters. And then I could also go with DAC. Notice, none of the letters that I used in any of these arcs involve this guy. You're never involved the center when you're naming arcs. Okay? So what are the major arcs of the circle here? We're going to name 4 of them. I'm going to name ACD. Again, these are more than, in this case, these are more than 180 degrees. A to C to D goes all the way around, almost all the way around the circle. DCE is a major arc. Okay, D to C to E, D around to C to E is more than 180 degrees. CAE is a major arc, and ADC is a major arc. All of those are all major arcs, and I'm sure there are a couple more that you could come up with. Okay, again, major arcs have 3 letters, minor arcs have 2 letters, semicircles have 3 letters. Major arcs are more than 180. Minor arcs are less than 180, and semicircles are exactly 180 degrees, or half. Okay, so let's take a look now at arc measure. Arc measure is the measure of a minor arc is equal to the measure of its corresponding central angle. So whatever the central angle is, remember, a central angle is an angle that starts at the center. Its vertex is at the center. So in this case here, you'll notice that the angle S is 50 degrees. That's the central angle. So if angle S is 50 degrees, then arc RT is going to be the same measure. Okay, the arc measure is 50 degrees. Okay, the measure of a major arc is the measure of the related minor arc subtracted from 360. So in this case, if you look at TQR, arc TQR is what's left of the circle. Remember, there's 360 total degrees in a circle. If I take 360 minus arc RT, which in this case is 50, that gives me 310. Now, very similar to segment addition postulate, we have what we call the arc addition postulate. The measure of an arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. In other words, in this case, arc ABC is made up of 2 arcs. It's AB and BC. So if I take AB and I add that to BC, that gives me ABC. All right. Okay, let's find some measures of arcs here. What's the measure of each arc in circle O? Arc BC. Arc BC is from B to C right here. And you're looking to see, in this case, is there a central angle? Well, there is. The central angle is 32. Again, the central angle is right here. It's 32. Then, therefore, the arc also has a measure of 32 degrees. Okay? All right, so arc BD now. Arc BD goes from B to C to D. In other words, it's made up of 2 arcs. It's made up of a 32-degree arc and a 58-degree arc. So if I take 32 and I add that to 58, that's going to give me in this case, BD is a 90-degree arc. All right, arc ABC. As you look here, arc ABC goes from A to B to C. Well, you'll notice that AC is a diameter here, which means that in this case, ABC is a semicircle. It's half the circle. So arc ABC has to be 180 degrees. It's a semicircle. And then finally the last one, which is arc AB. Arc AB goes from here to here, or A to B. You know AC, arc ABC is 180 degrees. Well, I can take 180, subtract the 32 that's left over from right here, and it's going to give me this arc right here. So if I take 180, take half of it, minus the 32, that's going to give me arc AB, which is 148 degrees, which is still a minor arc. Okay, so this concludes section 10.1, part 1. Don't forget to watch part 2 and then complete your WSQ.